Section 1.7 is on three-dimensional figures. Let's start out with a few definitions. A polyhedron is a solid figure with all flat surfaces. In the last section, when we looked at two-dimensional figures, we had polygons. In this case, since we're talking about a three-dimensional figure, we call it a polyhedron. A face is any flat surface of the polyhedron. An edge is the line in which two faces intersect each other. And vertex is the point where three or more edges intersect. So let's take a look at this pyramid here. So we have the faces, which are the triangular sides, and actually the square or rectangular base. The vertices, a vertex is any of these points on the edges here, and an edge is any one of these lines going down or even across the bottom where two of the planes intersect each other. Let's take a look at what we call a couple different types of solids. A prism is a polyhedron that has two parallel congruent faces that are called bases. This is an example of a hexagonal prism because the top is a hexagon, a six-sided polygon, and the bottom is also a hexagon. Those are considered the bases because they are the two parallel congruent faces. They're across from each other, they're parallel, and they are the same size. A pyramid is a polyhedron with a polygonal base and three or more triangular faces that intersect at a common vertex. Okay, so a polygonal base. So the base is going to be a polygon. In this case, the base is a triangle. It could be a square, it could be a rectangle, it could even be a pentagon. And then the faces are all triangles that meet at the top point, called a vertex. A cylinder is not a polyhedron because it does not have all flat sides. We just refer to it as a solid that has parallel congruent circular bases, and as I said, it's not a polyhedron. So the bases are the circles on the top and the bottom, and then the lateral face, if you could consider it that, the lateral part of it is the kind of like the label on a can of soup. A cone is also not a polyhedron, but it's a solid that has a circular base and a curved surface that meets at the top with a single vertex. So the base is a circle and the vertex is this point at the top. And a sphere is also not a polyhedron, and it's defined as the set of all points in space that are equidistant from a given point. And you all know what a sphere is. It's basically a ball. Okay. Let's take a look at a couple of problems here right out of the book. It says determine whether each solid is a polyhedron, then identify the solid. If it is a polyhedron, we need to name the bases, the faces, the edges, and the vertices. So 1A here, that's actually a cone. That is not a polyhedron because not all of its faces are flat. It actually has the curved cone part of it, and it is indeed a cone. And since it's not a polyhedron, I don't have to name the rest of those pieces. Number 1B here is indeed a polyhedron. Oops. And this is a triangular prism because it has two, triangular prism, because it has two parallel congruent faces, and that would be the triangle in the front and the triangle in the back, and those are called the bases. Now, a confusing thing about a prism is the base is not always on the bottom. The bases are going to be the two shapes, the two sides that are the same shape, the same size, and are directly across from each other. So in this case, the bases are going to be this triangle GHI and the triangle JKL. Since this is a polyhedron, now we need to name all of the parts here. So the bases are going to be triangle, as I said, GHI and triangle JKL. Okay, the faces are the other planes, so that would be the plane on the bottom, and remember we name a plane with at least 3 letters. I'm going to go ahead and use all 4 so you can see it a little better. So GILJ And then how about this one on the right-hand side here, HKLI. And then the rectangle that's kind of on the back there, GHKJ. Okay. All of the edges, and these are going to be the lines. So let's start with the triangle in the front. So I have GH, HI, and GI. And then the triangle in the back, I have JK, KL, and JL. And then I have the edges that kind of join the rectangular planes. So IL, HK, and then the one in the back, GJ. And I think that's all of the edges. And then the vertices are the points. So that would be point G, H, I, J, K, and L. Okay? Here's a cool chart out of your textbook. There are 5 shapes that are called platonic solids, and these were identified by the Greek philosopher Plato. The cool thing about platonic solids is they're all polyhedrons, and all of the faces are congruent. So for example, here in this tetrahedron, it has 4 equilateral triangular faces. So all of the faces are equilateral triangles. A hexahedron, or more commonly known as a cube, has 6 square faces. Each face is a regular quadrilateral, that is a square. An octahedron has 8 equilateral triangular faces, so all of its faces are equilateral triangles. A dodecahedron has 12 regular pentagonal faces. It's a little hard to see from this picture, but it's actually 12 pentagons in a 3-dimensional solid. And an icosahedron has 20 equilateral triangular faces. And it's a little hard to see from this picture, but it's actually kind of cool that you can put 20 equilateral triangles together and make something that's kind of roundish. We're talking about 3-dimensional figures. We don't talk about perimeter and area. We talk about surface area and volume. And surface area is the sum of the areas of all of the surfaces of a solid. So if we were to take the area of each flat surface of a solid, or even if it's a curved surface, the area of each of those surfaces and add them together, that would be your total surface area. And the volume is the amount of space that's enclosed by a solid. So surface area is going to be in units squared, volume is going to be in units cubed. And here's a chart out of your textbook that goes through the surface area and volume formulas for all of the shapes we've talked about so far. Just to define a few things, whenever we're using big P, that's going to be the perimeter of the base, and that's going to come up in a couple of these. Height in a prism is going to be the distance between the 2 bases. When we're looking at a pyramid, we're going to have to deal with the perimeter of the base, which in this case would be a, let's say, a square. And the area of the base, so that's big B is going to be the area of the base. And notice we have this letter here, L. L refers to the slant height, and that is the height of any one of the triangular faces. So it's actually on the surface of the pyramid. So it's the height of that triangle right there. In a cylinder, we only have 2 dimensions to deal with. That is the radius of the base and the height, which is the distance between the 2 circles. And in a cone, we have radius, which is the radius of the circular base, the height, which is the distance from the center of the base straight up, or in this case down, to the vertex of the cone. And then the slant height is the length of this slanty part out here. And you'll notice that actually makes a right triangle inside the cone. And in a sphere, we only have 1 dimension, and that is the radius, and from the distance from the center to any point on the sphere. So let's take a look at a few examples here. So we need to find the surface area and the volume of each of these solids and round it to the nearest tenth. So for 2A, okay, what we have here is a cylinder, and I'm noticing that the radius is 6 feet and the height is 18. So let's go ahead and do our formulas here. So the surface area of a cylinder, remind myself here, is 2 pi RH plus 2 pi r squared. Okay, so it's pretty straightforward. Just plug in the numbers, 2 times pi times 6 times 18 plus 2 times pi times 6 squared. I'm going to leave pi in my calculations until I get to the very end. So 2 times 6 times 18 gives me 216 pi, and 2 times 36 gives me 72 pi, or my surface area is going to be exactly 288 pi, which is approximately 904.8 feet squared. Now my volume of this is going to be pi times the radius squared times the height, pi r squared h. So pi times 6 squared times 18 gives me exactly 648 pi units, which is approximately 2035.8 feet cubed. And remember, volume is cubic. Okay, my second example here, 2b, this is a rectangle. And rectangles can be, a rectangular prism. A rectangular prism can be a little difficult because it actually has 3 pairs of parallel congruent faces. I could consider the top and bottom the bases, I could consider the front and back the bases, or the left and right sides. And it really doesn't matter which one you choose, you're going to get the same answer either way. So I'm going to go ahead and choose the bottom as my base. So surface area of a prism is the perimeter of the base times the height plus 2 times the area of the base. So the perimeter of the base is going to be 5.2 plus 10 plus 5.2 plus 10, or 30.4. The height is the distance between these two bases, which is going to be 6, and 2 times excuse me, the area of the base, and I chose the bottom to be the base, so that's going to be 5.2 times 10. And that's going to come out to 182.4 plus 104, or my surface area is going to be 286.4 centimeters squared. Now for the volume of this, I'm going to use the formula area of the base times the height. The area of the base is 5.2 times 10. The height is 6. And actually, looking at the diagram, this probably brings to mind the formula that you may have learned in pre-algebra. So for the volume of a cube or any rectangular prism like this, it's basically length times width times height. So in this case, plugging that into my calculator, it gives me 312 centimeters excuse me, cubed. Okay, and 2c, this is a cone, and let's go ahead and identify what we have here. 15 refers to the radius, 8 is the height, and 17, that's my slant height, which I use the letter L for. So the surface area of a cone is pi RL plus pi r squared. So pi times the radius, which is 15, times the slant height, which is 17, plus pi times 15 squared gives me 255 pi plus 225 pi or exactly 480 pi, which is approximately equal to 1508.0 inches squared. Volume of a cone is 1/3 pi r squared h. Oops, not up there. H. Plugging those in, 1/3 times pi times 15 squared times my height, which is h. Now here's a little hint when you're using 1/3. Don't use just 0.3. 0.3 is 3/10. It's not 1/3. Easiest way to do this is to think of 1/3 as dividing by 3. So in my calculator, I'm going to do 15 squared times 8 and then divide that by 3. That gives me 600 pi, which is approximately equal to 1885.8 1.0 inches cubed. So in this section we learned a lot about polyhedrons and other three-dimensional figures, looked at their surface area and volumes.